Last time we saw the print function and how we can use it to print variables in single line and multiple lines as well. So let's explore the print function a bit more. Let's suppose you want to print some meaningful sentence in the code, and so in order to do that we're going to use inverted commas. We're going to use inverted commas and we're going to type in the sentence. So let's type data science and then we press print and enter, and we can see that this is the output we get. So this tells us that we can use the print command to write down text. We can print text and we can print numbers, we can print variables. We can actually do the same thing in the same sentence as well. Like for example, if we want to write variable value is equals to 45, I'm going to print it, and so this is the result. It becomes quite useful whenever you want to specify what you're trying to visualize. Okay, so the same goes with a couple of other things. For example, if we want to print characters, we're going to use single quotes. Okay, so one more thing is that if we want to write text, we can use double quotes or single quotes. So if I write single quotes and variable, it gives me the same output. So it can either be single quotes or double quotes to write text, but that is the rule we get. Okay, so let's look at another example. If you want to print something in another line, for example, I want the value of 45 to be in the other line. So whether it is the numerical value or the text, let's look at an example for both of them. So variable, or should I say data, and I want to print science in the next line. So what I'm going to use I'm going to use an end L character, which is the new line character, which is the \n. This ensures that the succeeding word or sentence is written in the next line, science. So now we have the data science in the other line. So, but there's a thing you should notice here, that the science is a little bit indented towards the right. There is a space between the word S. This is because we have used space over here. So if we remove the space, let's see what happens. Okay, so now there is no indentation and we have successfully printed science in the other line. And the same concept applies with the numerical value. And so now you should ask yourself, where is this space coming from? Is this space coming from here, or maybe it is something else? So what happens if I remove the space over here? It is still there. There is no space over here. This is just you can say the printed output of the numerical value. The space over here, the indentation, although it seems like it is an indentation, that is not exactly an indentation. It is not caused by the text we printed out. Okay, so these were a couple of ways we can use the print value, and we can use it to print the end statement and other things. There are a couple of functions, but before we go into them, we need to learn about operators. Okay, so let's learn about a couple of operators. We're going to start with the mathematical operators. There are a couple of mathematical operators which we can use. Let's go with addition, subtraction, division, and multiplication, and exponent. Okay, so we have these. Okay, they look a bit, so we're just gonna change this into bullet points. And if you want to add bullet points, we can use it by using this dash. So we can use it using the dash. So if you want to add an asterisk, that would cause it to be bold. If you want to bold it, then we will be using it double asterisks to bold the text. So by adding double asterisks and dash, we can convert our text into bullet points, which are written with bolded text. Okay, so regarding operators, it's simple as mathematics. Addition does with plus, subtraction minus, division divide, multiplication multiply. An exponent, it is the power of the, okay, so the exponent might be a different, somewhat different than the traditional notation of mathematics, but apart from that, all other operators are just simple mathematics. So let's get into it. So 3 plus 4, we have 7, and we can do these operations with other. 5 plus 4 minus 2, 5 multiplied by 3, and we have 15. And division, let's divide 16 divided by 8, so we have 2.0. So let's look at this output. The output is 2.0, so the output is in points or float, because the number and the division output can also be in points. For example, if I divide 16 by 5, I would get 3.2. The division operator outputs the number in floating points. However, we will see later on that if we want to convert the floating points into integer, we will use typecasting, and we use a different function, a different default built-in Python function for that. Okay, so let's look at exponent. So exponent is somewhat similar to multiplication. Since we're in exponent, we're just going to repeatedly multiply by the exponent number. So if we have 2 raised to power 3, I will multiply 2 3 times. 2 into 2 into, so the output should be 8. So if I want to write an exponent term, I would write 2. Since the number of values over here is 3, I would like the repeated multiplication of 2 with itself 3 times. So I will write 2 asterisk 3. So as you can see, this is the representation of using exponent, or you want to repeatedly multiply a number with itself, you will use the double asterisk for this function. Okay, so now so far we have quickly seen the different operators. Just one thing I need to cover more: if the value on the right side for subtraction is greater, let's say this, so the output should be negative. That's pretty obvious, it's just simple maths, nothing more. And Python follows the DMAS rule: division, multiplication, addition, and subtraction. So if I write here 16 minus 2 plus 4 into 1 divided by 5, so the output should be 14.8, and it works from left to right. So the first operator would be division, and the second, the output would be multiplied by 4 and added into 2, and so on and so forth. So this is the way. So Python will follow the DMAS rule: division, multiplication, addition, and then subtraction. Okay, so we have seen about the basics of operators. Now let's do something interesting. Let's see if we can do the same operation with variables as well. A plus B, and the output should be 17. Okay, so let's say I want to store the output into another variable. I would write total is equals to A plus B, and then I would print total, and the output would be printed, and that is 17 as well. So in this way I have stored the sum into the total variable. So one more point I need to add: whenever you're writing code, the variable names should be meaningful. For example, I've been using A and B, and I've been using simple characters for that, but when you're writing professional or code at an industrial level, or you're working on a project, research project, which needs to be open source, or which another human being will read, and his ability to read it properly and to comprehend it will depend upon your coding skills. And that is what defines a good programmer: to write a readable and comprehensible code. So rather than using A and B, I should write it number 1, and this would be number 2. And this would suggest that I'm actually adding these two numbers. So now my code is self-explanatory. So this seems rather not useless and not really necessary at this stage because the operations are quite simple. It's quite obvious that we're going to add. So why do we need meaningful variable names to tell us that? It's because when we are doing something, code that is not so basic and traditionally comprehensible that many of the programmers don't even know about, so then these meaningful variable names convey a certain message. Although we also add comments with the code, but a good code will always have meaningful variable names and it will be well commented so that it is readable and comprehensible to anyone who reads it. Okay, so let's apply the same addition concept to strings as well. Although in strings it serves as concatenation. We will look at concatenation in depth when we study strings, but I want you to apply the concept of addition over here just so that you can connect this with the printing, so that you can just learn a couple of more about printing, which we might be using ahead so that you won't get confused. So I'm just going to introduce one little concept. So what I mean is that we've seen that we can do this, so we can also do this. Okay, I've done something wrong. What did I do wrong? Okay, let's just initialize these numbers again. Okay, maybe my system went offline for a bit. Okay, so whenever this happens, you just have to run the cells again. So this is another important thing. If this happens, it means that you need to rerun the cells above. Okay, so we can do this using print. So we remember that we can type data science okay, so we can also, after studying the plus operator, we can also do something like this. So in this way we are going to concatenate these two strings into one string. So the output should be data science. So there's no space between it. So in order to remove that, we're going to do this. So you must be thinking what would happen if I apply different operators. Okay, I'm going to leave that to you to explore on your own, but it should give you at least a sense of that we can actually apply the operators into strings as well. We will discuss the concatenation operation, which we have just seen, in more detail when we will be studying strings. But for now, this is just a little bit information I wanted to give you because I might be using this printing statement in this syntax in a couple of next lectures. So it was important to tell you that. Okay, so far we have seen the different operators, addition, multiplication, and all these were mathematical operators. So let's look at another category of operators which we call the comparison operators, and which enables us and gives us the power to compare two different variables, two different values, two different strings, and so on and so forth. So let's look at the comparison operators. So the first and foremost comparison operator we will discuss is the equality operator, which is represented by this. So this is a binary operator, which means that this should be given two values to actually enable it to perform, to give us the output. So one value should be 5 and the other should be 5. So now we've given it two values. So this equality operator tells us whether the left value is equal to the right value. In this case it is, so it will return us true. So these comparison operators are also known as Boolean operators because the output they will give us is either true or false. So if I were to replace 5 by some other number like 6, it would give me the value of false. Okay, so let's look at the opposite of equality operator, which is the not equal to operator. So let's do the same operation. This time let's try different numbers. Okay, so let's check if 8 is not equal to 9. It is true because 8 is not equal to 9. This exclamation mark shows is actually the not, and the equal to is the checking whether is checking equal. So not equal. So this operator is, in order to remember it, it checks that whether the left side value is not equal to the right side value. and if it is true, it returns true. Somehow, if we actually want to check if 8 is not equal to 8, which is in fact false, it should return false. Okay, so it was pretty basic so far, and we can apply the same concept to variables as well. If you want to initialize 5 and 6 and check a is not equal to b, which is true, and a is equals to b, which is false. Okay, so after looking at these comparison operators of equal to and not equal to, let's move on to another operator which would actually check whether a value is greater than the other value or less than the other value. So that those operators are greater than and less than. Is 5 greater than 5? No, they're actually equal, so the output should be false. Is 5 less than 5? No, they're actually equal, so the output should be false. Pretty basic and straightforward. Let's check if we can get true from it. Is 5 less than 6? Yes, it is, so we'll get true. Is 6 greater than 5? So yeah, it is, so it just checks that. Let's move on to greater than or equal to. In greater than or equal to, it checks basically two things: whether the value is greater than, and if it is not greater than, is it equal to. So like before, when we were checking the same values in greater than or less than, it was returning false when both of the values were equal. In this particular operator, it's not going to do that. It's going to tell us that if these values are equal, it is true. So let's check it. Yep, it is the same. Same goes with less than or equal to. And it will also return true when we have less. So it's basically checking two things. So less than equal to and greater than equal to have merged the greater and equal to, greater than and less than operators with the equal to operators. Okay, so we have seen a couple of comparison operators. So let's move on to logical operators. So the logical operators deal with the Boolean values. They tell us whether two statements are true or not. So the three types of logical operators we will be studying are basically that exist are and, or, not. Okay, so these are the three ones. So there are the logical operators like NAND or NOR, but basically they are made by combining these operators. So if you want to make them, you have to use these operators to make them as well. So let's check these out. If we have these Boolean values like true and false, and if you want to check what would happen if we apply the AND operator. So the AND operator is represented by writing AND. So I'm applying the AND operator between a false statement and a true statement. So it is false. So this tells us something about AND. What it tells us that it is something like multiplication operator between zeros and ones. So that basically we're talking about Boolean values. So if it is true and true and false. So there's one thing you should notice over here, like if I'm writing true, it is not in blue color like the one above, which means that the first letter T should be in capital. Okay, and false, and we have false and false. One other thing you should know, that it doesn't matter the position of false and true. So what I mean by that is whether it is true or false, true and false, or whether it is false and true. It is actually the same thing. Okay, so let's see. So we've done something wrong here. What we've done wrong is that we've not used the print statement, and whenever we're not using the print statement, only the last line of code will be printed out in the kernel. So let's use the print statement to verify our experiment. And we have true, false, and false. So this is the functionality of AND. It can only be true if both of the values are true. Otherwise, it is always false. So if either of the two values is false, the result would be false. Moving on, let's talk about the OR operator. So let's just copy this, and I'm going to replace the AND operator with the OR operator, and we write it with the same OR. And so what does the OR operator do? The OR operator works a little bit different than the AND operator. What the OR operator does, that it is something exactly opposite of the AND. It will always be false if both of the values are false. And if either of the values is true, it will always be true. So let's run this. So as you can see, it is only false when both of the values were false, and it is always true when either of the values is true. Okay, so we have seen the two operators, AND and OR. Now we're going to talk about the NOT operator. The NOT operator is not a binary operator. It is a unary operator, which means it does not need two values. It always needs one value. So we're going to write NOT, and we're going to type true, and the output should be false. And what NOT does is, it's pretty simple. It just converts input Boolean value to its opposite. So if it's true, it will convert it into false, and if it's false, it will convert it into true. So as you can see now, it is true. So not false is true and not true is false. It is the same thing as the English language, right? So it is not true, so it's false, and not false is true. So now the question is, why is it meaningful? These logical operators, we're using true and false. Like, why or when is it useful? Why do we have these operators? So the thing is, if you remember previously, we saw these comparison operators, right? So the output of these comparison operators was false or true. Okay, so this tells us something, that how we can use logical operators to come up with more strong programming instructions, which would ultimately enable us to compare two statements or expressions. Let's have a look at this. So imagine we have two statements. 5 is greater than 6 and 6 is less than 5. So the individual output of these two equations would be 5 is greater than 6, false, and 6 is less than 5, false. So what if I need to compare the two, and I'll say, let's put an AND in them. Okay, so I'm comparing two different expressions, two different outputs. So the output should be false, and false is false. Okay, so we do the same thing with something different this time. So this time one of the outputs should be true, right? So the output should be false. This is a very powerful tool when we are using the if-else statements, whenever we are using the while statements, which we will see later on in the course when we are studying the for loops and the while loops and the if statements. So this gives us a lot of power over comparison operations whenever we are comparing two different big expressions. Okay, one last thing I need to add before we end this lecture is we need to talk about operator precedence. So operator precedence, what is the operator precedence we have for AND, NOT, OR, and OR? So the first is NOT, the second is and in the same level we have OR. So you can say that this is the operator precedence for these three operators. So what do we mean by operator precedence? The operator precedence tells us that if we have these three operators in the single statement, in what order will they be executed? So the first operator will be NOT, and the second will be AND and OR. So let's try something. Let's look at an example. We have NOT true and false, or false or true. Okay, so what would be the output for this? So the first operator that will run is the NOT. So the output would this of this would be false. So, and then it doesn't matter which of the AND or operator would run first. So let's go with this one. Not true is false, false and false is false, false or true is true. So the answer should be true, and it is. So this is the operator precedence we have. So I would suggest that you try different examples with it, and you can play with these things you have learned today, and try and experiment new things so that you can learn and experiment and practice, and it becomes better and better.